Hello, welcome back, folks. Told you it wasn't going to be too long of a break. We've returned. It's almost time to get underway with our second talk, and we've got the wonderful Trista Pan, who is the Chief Technical Officer and a co-founder over SphereX. She's here to run you through PostgreSQL and how you can empower it via the use of Apache sharding sphere. Almost fluffed that up. I'm not going to fluff it up anymore, though, Trista. I'm going to pass it across to you, the professional on the matter. Enjoy the talk. Folks, remember, there is going to be a Q&A section at the end, so if you have any questions to post to Trista that pop in your mind as the show goes on, be sure to drop them in that section, and we'll relay it at the end.
All right, thanks. Hello, everyone. So wait a moment. I just make these slides work it. All right, okay. So I'm so happy to give this talk around this PostgreSQL about the distribute, about the cloud, because you know all these words are the keywords or hot words in these days. So today I just want to give another solution to help you to leverage the PostgreSQL cluster and to create your distributed, secure database ecosystem, especially on the Kubernetes, right? So it's a solution for all this topic. But before introduce that, I can just give a little introduction about myself. I'm the Trista Pan, the Sophia ES co-founder and the CTO. Because I spent a lot of time in the Apache Software Foundation. So my open source title, it's Apache member and incubator project mentor. So sometimes I do my professional work about the distributed database, about the like cloud or Kubernetes, or sometimes I just give some tips or suggestions to the open source project to help them to create their tech community. Yeah, so that's the brief introduction about myself. And if you're interested in our topic about the open source or the business or started up, and also about the databases or an AI management platform, you can just give a look on my Twitter or LinkedIn. So I will post some article there, right? So let's entering today's topic about my title, right? This topic. But before that, I need to introduce the background, because you know, if we have no issue, if we have no problems, nobody want to do anything to change your database infrastructure, because that will create some potential dangers to our infrastructure, and maybe will create some harmful emphasize for application, right? But currently, actually, we entering into the big data world, right? So big data means we have the new requirements for our database. That also means the history database, they are so great, they were so wild, but gradually we found no, it's not enough to support the modern application, right? So you can see here, at today, at this big data world, we found that we need more scalability, and we want each query to become faster, even though we have a tremendous data to manage, right? We also need our, like the infrastructure, have the elastic scale in, scale out capability, or make our data become more security, or high availability, resilience, or HTAP, this new word for architecture, right? So all of them features or requirements from the big data world. The second one is about cloud. As many people now are move their infrastructure into the cloud, or now they're create their new infrastructure directly on the cloud, right? But for history infrastructure, how do we deal with such issues? Moving our data, moving our infrastructure to the cloud, especially around the databases, right? So we need to consider how to do the cloud native, multi-cloud, and do not be locked in one data cloud vendor, right? Also, we'll consider database as a service is good for me or not, right? So there are two major, the changes in this world, and they will require different areas, problems, or issues for our database infrastructure, especially when people meet two, atmosphere issues. It will make a mixtured issue for our problem for us to solve, right? You need to consider cloud. You also need to consider the new requirements from big data. So for any user, which the solution is best for me? People will have such questions, right? So you can see here, distributed, database, and cloud, right? That's all of them confused us. So, but now when we see the history or see the evolution progress, you see here from at the beginning, maybe they're just a monolithic database, PostgreSQL or MySQL or Oracle or SQL Server. They just on the premise. They work well for our history application. But now you found that people willing to choose the database on the cloud or RDS, right? Or on the premise or a private cloud. So you will see these changes now. But later on, especially these days, people also will consider the distributed, because if it's just a monolithic database, whether it's on the premise or on the cloud, people cannot deal with the new issue from the big data. That is so much data for us to manage it. And we also need our database become productive and support our questions so fast, right? So we need the distributed architecture around the databases infrastructure. So you can see here MongoDB or PostgreDB, they adopt their distributed architecture to develop their new solution for our database infrastructure, right? But when we see the capability of our databases, you will find actually a databases, they have two major functions. First is computing, right? Second is storage. And for the history, for the monolithic databases, actually they just merge the computing power and the storage power together and deploy this single computing plus storage capabilities product in one place. But at this distributed architecture, you have found it adopts the computing storage splitting architecture. That means their computing nodes and their storage nodes, it's sharding architecture. It's distributed in anywhere. The storage could on the cloud or on premise, but their computing nodes could be deployed far from their storage nodes, right? So that's the magic of the distributed system. It also means we can have the elastic skew in, skew out based on people's scenarios, based on users' needs, right? So that means you just pay for your what you really need, right? So that's the distributed database architecture. But today, I also want to use this architecture to leverage your PostgreSQL cluster to make it become a distributed system, and also consider how to put this distributed or sharding database architecture on the Kubernetes, right? Because when our service become microservice, right, and our application is it's living in the Kubernetes, you will consider how to put our distributed databases also in the Kubernetes. So that's the question for everyone, no matter for our end users or for the vendors, database vendors. All right. So this solution actually have another benefit. It's not just about, hey, I just make it become modern databases and architecture, right? Help user to solve the scalability and the availability, or have the high performance, can help users to manage their tremendous data, right? another benefit from this solution, the solution from I will introduce later on, is that it can help you leverage your PostgreSQL databases or MySQL databases, because everyone knows that our infrastructure, it's in the progress, right? We cannot ignore that the current existing database infrastructure. Now it's worthwhile, but people will worry about their future, right? If we just totally change our database architecture, that means you need to pay more time, more efforts, and maybe that will give you more potential dangers for your infrastructure, right? Nobody wants to pay a lot just for upgrading your databases cluster, right? So that means at this point, your MySQL, PostgreSQL were so well, and later for next step, we just upgrade it with lowest effort and cost, make the data migration or database architecture upgrading become fluent, right? So that's the major point for my solution I will introduce later on, and also how to do the multi-cloud and no locking, achieve that goal, right? So I just want to first introduce the benefits of this solution, and you can base your scenarios to use it or not, right? So how to reach that goal? We needed to use an open source project named Apache Sharding Sophia, because like I said, the key point here is that we need to use the sharding architecture. We need to use the distributed architecture. That means your computing nodes and your storage nodes of a database system will become distributed and will be deployed or in anywhere, right? So that means the computing storage splitting architecture. So here, if we want to upgrade our current PostgreSQL cluster, become a distributed one, then we need to consider now the PostgreSQL database will become, maybe I can give the next slides for that. Now, or Oracle or MySQL or PostgreSQL could work as the storage layer because they have the basic powerful storage capability, right? So we can just upgrade or import a global computing service or computing nodes, computing power. Then this computing layer plus your existing storage layer, your existing databases cluster will group or create a new distributed database solution. That means your distributed database, right? So you can see here this computing layer, it can help you to distribute your queries in different, in the different shards. Shards means one PostgreSQL nodes, it can work as a storage node. It's also called a shard, right? So in this distributed database system, your computing layer is distributed because now I just gave one local here. Actually, you can deploy 2 or 3 instances for your cases. Also, your storage, that not only means you just have one PostgreSQL, you have many PostgreSQL here, and all of the PostgreSQL will become a storage layer, storage cluster, right? So, or any user, they will just visit this computing server. So this computing server will help you to send these queries to different PostgreSQL to store it or gather result from the local, and then do the global computing, get the compute the final result to return that result to our end user. So that's the basic idea for this upgrading. That's why I cite another benefit from this. That means we can just solve the one requirements for our distributed modern database cluster, become a distributed or sharding one. And then because your storage nodes and your computing nodes can be loaded in different area, right? So here you can put your computing nodes just in the Kubernetes or on any other cloud, and your storage nodes or storage layer, you can choose the on-premise PostgreSQL, right, or existing PostgreSQL or RDS. But you can just select your computing server to visit, give their a privilege to make the computing power nodes to visit your storage node. Then for an user, they will merge. The computing layer and the storage layer will group a new distributed database system, right? So if you found that you need more computing power, not storage power, right? You can just use the operator to make this computing layer scale out, right? At this moment, you just make your distributed system have the have the more like computing power, but will don't do anything around your storage, right? So that means this upgrading, just upgrade your computing layer, just make your computing power become larger, right? So that means this flexible scaling, scale out, you can separately separate scale in the scale in or scale out the computing layer, or scale in or scale out the storage layer, right? It's separated, right? It's the flexible, the scale in or scale out. So here you can see this logo. That's the Apache Sharding Sophia. I just want to introduce here, because if you can get my point about how to leverage your PostgreSQL to make it become the distributed one, to deploy different components of this distributed system anywhere, then now you need to find who can help us to work at this computing layer. That means Apache Sharding Sophia. Apache Sharding Sophia, if you see his slogan, actually it's the ecosystem to transfer your any databases into a distributed one, and also enhance this distributed system with other wonderful features such as data encryption, or the global authentication, or the SQL audit, and all the useful features around your database system, right? So it's not just about the scaling, scale out, it's just not about the sharding architecture. So we can use it to work as the computing layer, the computing nodes. So actually, this Apache Top Lab project has been open sourced for more than 5 years. So it has a mature community. It already released more than 14 times and have many stars or contributors, and have the wonderful clean instruction. So if you have any questions, or you just want to have a quick start, you can just look at a document or ask your question on this community. All these guys are so nice to give your help or answer your question. So that means it's open source, right? So next part, I want to give more introduction about this project, and especially around its features or functions. If we really want to use this project, what does this project can help us, right? So you can see here, this project actually provides 2 clients for us to choose based on user scenarios. First one is Sharding Sophia JDBC. It's a lightweight driver for your Java application, and you can just use Maven and import Sharding Sophia JDBC. It can help you manage all of the Postgres or the MySQL or Oracle or SQL Server database cluster, and also can make this database cluster. It's not just about the database management. It's also about how to group this separate storage node or Postgres instance become a sharding architecture, right? Each shard contains part of your whole data, right? So different shards contains different shard of the data, and they will group a single logic databases for or and user for your application. So that's the magic or feature of Sharding Sophia JDBC. And Sharding Sophia proxy, it shares the same features with Sharding Sophia JDBC, but it has a different, deploy style. You need to deploy Sharding Sophia proxy in single server, right? So it will provide the TCP service for our application. For our application, you can just send your queries to Sharding Sophia proxy. You can work it can work as distributed or sharding database server. So you do not need to change your connection approach to your existing databases. PostgreSQL, maybe you use Navicat, or you use the PG driver from your application to visit this your PG server, right? So now you don't change all of the approaches. You can just change the IP and the port or the host name to the Sharding Sophia proxy, and it still works well. Yeah, so Sharding Sophia proxy also can help you do the sharding, data sharding, or elastic skewing, skew out for your data, right? Because now maybe you found I just need 4 PostgreSQL instances, but later on you have more data to manage it, right? So maybe you need to skew this database from 4 to 8 or 1,000 instances. Right? So Sharding Sophia proxy can help you do such the data moving or data migration process. And last one about rewrite splitting. Oh, that's about the traffic governance, because I know that now people want to leverage the replica instance to help you, rebalance your read queries, right? So actually, Sharding Sophia also have such features. It can automatically help you send the queries, especially real queries, to different replica. So you can see Sharding Sophia proxy or Sharding Sophia JDBC as a proxy or the load balancer for your database cluster. So wow, actually there are so many, the features of Sharding Sophia JDBC or Sharding Sophia proxy. You can pick up 1 or 2 or 3 to use. It's based on your cases. So actually, internally, the Sharding Sophia proxy or Sharding Sophia JDBC, when it receives the queries, it will, do the SQL pass or the SQL optimization, or to, pick up the target PostgreSQL or MySQL instance to get the final readout, right? To merge the readout. So that's the steps that Sharding Sophia how to handle a SQL. And based on this basic kernel process, it can provide or end users such wonderful features. Yeah. So I have no enough time. So that's technique about the internal process. Yeah. All right. So next part, it's about your architecture, because maybe, here is the before, that's the after. Before, your PostgreSQL or MySQL cluster just located in different area, maybe on the cloud or maybe on the private cloud or on premise. But if you want to use such features, you don't need to do anything to your databases, because you know that if we really want to do something about our database, that means there will be some potential danger, right? Nobody knows what will happen if we do something for around our infrastructure, especially about our databases, because the company's most valuable stuff, that's the data, right? And data located in the databases. So here you can just, import Sharding Sophia into this system, into this workflow, and here you don't need to do anything about your infrastructure and your data and databases. And if you want to use such features or upgrade your database clusters, you can just import sharding sphere between your application and your databases, right? Then you can leverage such features. Yeah. So another part, I want to introduce the distributed SQL. So what's the power of this chapter? I mean, think about how your application connect or talk with your databases. I guess people will use SQL, because SQL, this language for your application or for an user, is so native way to like talk with your databases, right? But now, if now you know that because you use the sharding sphere, because you upgrade your Postgres cluster become a distributed one, that means this new database system have some new capabilities, right? So how to make your end user or make your application use such features, right? The best way is that, I just want to use the way, the approach I get used to. That means the SQL. So here we create another SQL language. It's the SQL-like language for your new databases system. This is sharding system. That means the distributed SQL. So distributed SQL, it's like the sharding sphere SQL dialect. You have the MySQL dialect, right? And PostgreSQL SQL dialect. Here, another new one. So you use the distributed SQL to help you like just comment or input or tap some of the distributed SQL, and like this new system, especially like this computing server, to know what your expectation. So here you found, I give some example here. For example, if you want to create a new table, you will type like create table, order table, right? Blah, blah, blah. But now here you can create a sharding table, right? It's so similar with your old create SQL, but have another new keywords here, sharding. That means, or application just tell sharding sphere or tell this new solution that, hey, guy, I don't want to create a common or standard table. I want to make this table become a sharding one, right? So by use this distributed SQL, you can like drive this new database system to help you do more sharding databases and features or functions, right? So that's a grateful feature. I mean, actually help our end users to import this system to your databases, currently databases, and make you become fluent and easily to learn about all of the stuff, right? So the next part, okay, I have some minutes, so I will give this example. And now, okay, I think what you said is interesting to me, and I want to do some demo to demonstrate it's okay to help me solve some issues. So this chapter or this session, I just give you my cases and how to use it, deploy it, and create this title, right? Distributed secure databases. Now, I want to use the we provide sharding sphere chart to help you to use the Helm to pull this image and deploy this image to the Kubernetes. I mean, you can just use the Helm commands to deploy whole sharding sphere, this cluster, right? Like I said, now if you want to have more computing power, you can deploy 3 computing nodes. If you just want to do the demo, you can just deploy 1 computing instance. One sharding sphere instance. And for your PG and PostgreSQL, you can choose If you already have your PostgreSQL databases, then you can ignore this part. I mean, the left part. You can just use Sharding Sophia charts to use the Helm to deploy Sharding Sophia on the Kubernetes. Because you know that Kubernetes is born for application. It's born for microservice. All of the applications are stateless, right? So if you really want to put your production databases on the Kubernetes, I mean, people will have a lot of concerns about this solution. So here, we just put, another better way, because it's a demo, so I just use the Postgres chart to deploy Postgres on the Kubernetes. But in your production, you can just pull up or spin up your Postgres on the cloud or RDS or on premise. Just deploy Sharding Sophia. It's a stateless computing nodes, and it's so easy to scale out and scale in such stateless computing nodes on the Kubernetes, right? Stateless computing nodes is born for Kubernetes, right? So that means we can put our computing power of the databases on Kubernetes and deploy your storage nodes, PostgreSQL, of a database system anywhere, on Kubernetes or not, on premise or cloud, right? But today I just put them together on Kubernetes, internal Kubernetes. And then you can see here, clone this project and use the Helm charts to build it and deploy it. You can see here it's successful, and you can know the status and the service name right here. So the next part that you can use this. I just demonstrate how to use Sharding Sophia charts to deploy it. The Postgres chart, you can choose anyone, right? The next part, if we already deploy Sharding Sophia and the PG and Sharding Sophia PG are the necessary components of a distributed database solution. So here we can create these databases, deploy components of the databases. And now we need to use the distributed SQL to help us to put logic or create the table, put our table and databases into this distributed database solution, right? So here you can see I just map the IP port here and logging in. When you use the PG command to logging in, you found always so familiar with you. But here you can see the server is the Sharding Sophia proxy, right? So you log in and create the databases, and now which distributed SQL you need to use? It's you need to use this register, or add resources to the Sharding Sophia. That means like your Sharding Sophia or your computing nodes aware of your storage nodes. That means your PostgreSQL instance here. So the next part, we want to use the distributed SQL to help we create this sharding table. So for our application or for an user, if you log in or connect to the Sharding Sophia proxy server, you found maybe there is only one table named table order. But actually, if you log in your PostgreSQL instance or the storage nodes, you found this logic table is made of 4 actor table in different PostgreSQL instance here. And so we need to find the sharding key to help us to locate which row located in which instance, right? So, but all of these things is transparent for the application. But I just want to use the distributed SQL and execute it in sharding Sophia proxy here and sharding Sophia proxy here. We'll create a logical sharding table, the table order, but actually the sharding Sophia proxy will help us to create more shards in different storage nodes. And also, if you use the distributed SQL, you can also light the sharding Sophia proxy to help you do the data encryption. That means, for example, the telephone number, right? Maybe your application just send the telephone, the plain text to the sharding Sophia. I mean, this server, this database server, but this database server will help you automatically, decrypt the plain text into the ciphertext and store this ciphertext into the different PostgreSQL database instance. So even though some people visit your PostgreSQL instance, but they can't understand what's the meaning for your telephone number, because sharding Sophia already help you make it become the ciphertext, right? Right. So that's the logic architecture. In turn, this distributed system. Yeah. So, okay, I have no time, but here you can just refer to the slides to do this hands-on, demo. Create the sharding table and create an encrypted table, and then create and because you need to have such the strategy, and then create this table and insert some of the testing data. And testing data, you can see here, the telephone number is telephone 1111. And then you found, if you gather readout from your sharding Sophia proxy, you see the row is telephone 111. That means the plain text. But if you log in the actual PostgreSQL, you found here you cannot understand what's the meaning of this column, telephone number, right? So, okay, so I just spent, about 40 minutes to give this. First, it's about the solution. Second, about the new issue. The third one, give you the demo to help you totally understand what the solution it is, right? So if you really have some questions, you can just ask me here, or you can want to learn more about sharding Sophia this project. You can just, we already have a book totally to introduce all of the projects, other wonderful features around your databases. In this book, if you're interested in such books, actually now we have some of the free copies. You can just tag sharding Sophia account on Twitter. Maybe we can give you some of the copies to invite you to know more about this project. And if you really like the open source, we're so happy to welcome you to join here. All right, so that's all about today's talk.
Thank you, Trista. Really informative. Wonderful for you to run us through that. So now, folks, if you've got any questions, this is the time to pose them to Trista. I'm sure everything is within reason. We already have a few questions coming through, so I'll open up with one from Akash. Akash asked, what is the query engine here since Postgres is only used for storage?
You mean the PostgreSQL works at the storage?
Yeah. So they say, sorry, PostgreSQL, they say, what is the query engine as PostgreSQL is apparently only used for storage?
Yeah, because in this distributed system, the databases and the Postgres or MySQL, they are perfect to work as the storage. That means yeah. So what's the pain point of this solution?
I assume it's that them asking what the query engine is. Like, is the query engine something else? Is it a different piece of software, or is it part of Postgres as well?
Yeah, if you ask, you mean in this solution? It's not just the PostgreSQL. Also, other databases also can work as a storage nodes that I presented in these slides, the MySQL or the Oracle or SQL Server. It's not just the PostgreSQL, but it's the most popular open source DB.
Okay. And we've got a question in from Mirko. Mirko asks, how do you effectively combine big data processing tools like Spark, for example, and a distributed SQL system?
Sorry, big data? What?
Yeah, so combine big data processing tools. The other way that they worded it is, how do you efficiently move data in and out of a distributed SQL system?
Oh, okay, got it. So now actually Sharding Sophia has, you call it a tool, but for us, it's just a thread and happening in Sharding Sophia itself. So you can just use the distributed SQL, like the migrate data from the Postgres outside into Sharding Sophia database system. And when you execute such distributed SQL, and Sharding Sophia will handle all of the data migration process.
Okay. And so I think that was all the questions for now. But if people have any questions, they can just reach out via any of the socials, right?
Yeah.
Okay, fantastic. So what we'll do now is we'll round this out. If anyone's got anything they want to talk to Trista with, I'm sure she'll hang around the chat a little bit after this talk. But thank you, Trista. It's been very enlightening. Great to have you on.
Thanks, guys.
Thank you. All right. So that is going to be another talk done. What we're going to do now is we're going to have about a 10-minute break, just let you get a snack, maybe get parked back in your seat, maybe a little bit of time to talk to Trista or some of the other people who've been on so far. And then when we return, we will kick off our third talk of the day. See you then.